Okay, hello. Thank you very much for having me. And hello, everybody, and welcome to the Surgical Process and Ancillary Workflows talk. We are going to talk, what we are going to talk in this speech, we're going to talk about device sterilization. Can you hear me? I hear some noise, sorry. So, this is Mauro Larosa, and I am a technical product owner at DevDays with 12 years experience in managing surgical process and operating theater software. This presentation is composed by two different talks. In the first one, I'm gonna to introduce you the context and the process. In the second step, Riccardo Banali will show you the FHIR model that we created. Riccardo is a solution architect involved in the definition of a company architecture. Okay, so in this picture, you can view the surgical process. The surgical process starts with an outpatient visit and ends when the surgery is completed. During this process, a lot of activities are executed by different actors, nurses, surgeons, anesthetics, and so on. But our focus is on operating theater, scheduling, and surgery management. Because during this phase, the device kit sterilization are managed. Okay? Okay, so the context. In surgical process management, the kit sterilization is becoming increasingly important for patient safety and reducing costs. A device kit is a set of tools or devices. Try to think to a scalpel or scissors, for example, needed to execute a specific surgery. A single device, our scalpel or scissor, can be reused in different surgeries, and obviously the device needs to be sterilized for patient safety. The sterilization center is the place where devices are sterilized to be reused in a new surgery. So what we did, we created a FHIR model to manage three different, let's say, actors: operating theaters, device kits, and the sterilization center. We modeled a process that starts when a surgery is planned in a specific operating theater. During the planning step, the nurse defines which device kits are needed for the surgery, and then the sterilization center provides the device kits. Now, all the devices are physically in the operating theater, and they can be used by the surgeon during the surgery. Now we can go deeply inside the process to view the transaction involved in this process. In this print,
hello. Sorry to interrupt. So here we have a little break in the session. So there is 5 minutes break. So actually we are not yet started. So I'm sorry about that. But so basically, if you could wait, normally it starts in 1 minute. So could you kind of start again in 1 minute?
Yeah,
sorry
I started from the beginning.
Yeah, because indeed, like for us here, it was kind of a break and we didn't pay attention. So normally the time is 55. So it's kind of
okay.
now.
Sorry for this. Okay, sorry for this.
No, sorry about that.
Okay.
But so I think we can start now. Okay. So welcome everyone. So again, this is a virtual session. So the presenter is virtual, and actually we have 2 presenters. So we have Riccardo and Mauro, and they will speak about the surgical path and ancillary workflows, device kit sterilization. So the floor is really yours now. You can start. Sorry about that.
Okay. So I restart again, no problem. Okay, so first of all, thank you very much for having me. And hello, everybody, and welcome to the surgical process and ancillary workflows talk. So what we are going to talk in this speech, we're going to talk about device kit sterilization. This is Mauro Larosa, and I am a technical product owner at DevDays with 12 years experience in managing surgical process and operating theaters software. This presentation is composed by two different talks. In the first one, I'm going to introduce you the context and the process. In the second step, Riccardo Banali will show you the FHIR model that we created. Riccardo is a solution architect at DevDays, and he is involved in the definition of a common company FHIR architecture. So in this picture, you can view the surgical process. The surgical process starts with an outpatient visit and ends when the surgery is completed. During this process, a lot of activities are executed by different actors. Okay, so for example, nurses, surgeons, anesthetists, and so on. But our focus is on operating theater and surgery management, because during these two phases, the device kits sterilization are managed. The context. In surgical process management, the kit sterilization is becoming increasingly important for patient safety and reducing costs. A device kit is a set of tool devices. Try to think to a scalpel or scissors, for example, needed to execute a specific surgery. A single device, the scalpel or scissors, can be reused in different surgeries, and obviously the device needs to be sterilized for patient safety. The sterilization center is the place where devices are sterilized to be reused in a new surgery. So what we did, we created a FHIR model to manage three different so let's say actors: operating theaters, device kits, and sterilization center. We modeled a process that starts when a surgery is planned in an operating theater. During the planning step, the nurse defines which device kits are needed for the surgery, and then the sterilization center provides these device kits. Now, all the devices are physically in the operating theater, and they can be used by the surgeon during the surgery. Finally, the process ends when the surgery is completed. Okay, now we can go deeply inside the process to view the transaction involved in this process. In this picture and in the next, you can view two different actors: operating theater and the sterilization center. And they can communicate each other through FHIR transactions. The zero step is the dictionary sharing. Operating theater software and the sterilization center software needs to share some dictionary to exchange information. In this specific scenario, the nurse defines different kits based on the surgery types. This step is important because, for example, a knee replacement requires different specific devices than a hip replacement. Now we are entering the heart of the process. The process starts some days before the surgery execution. The surgery is planned, usually by the surgeon, and the nurse creates a request for specific kits required for the surgery. The sterilization center receives the order and verifies the availability of the kits. If the kits are available, the sterilization center reserves the kits for that surgery. The day before the surgery, the sterilization center sends the kits to the operating theater, and then the nurse verify the status of the kit. If the nurse needs, for example, 3 different kits for a surgery, he or she verifies that 3 different kits are now available in the operating theater. Now, the day of the surgery is arrived, and the nurse opened the kits and verified the status of all the devices. Then the surgery starts, and the surgeon uses the devices. At the end of the surgery, the nurse counts the devices again to be sure no devices are left inside the patient. As you can understand, this step is very, very important for patient safety. Okay, now my speech is ended, and Riccardo is going to show you the FHIR modeling. Thank you very much for having me. Please, Riccardo, go ahead.
Okay, you should hear me. Okay, so having described the process from, let's say, a functional point of view, I'm going to show you how we basically model this process using FHIR. So before going into the details of the process, let me introduce some assumption we did. First of all, the entire solution was modeled and developed using the FHIR messaging paradigm. The actors involved, as already mentioned by Mauro, are the operating theater, which is the responsible for the surgical process management, and the sterilization center, which manage the sterilization process of the surgical devices. The objects that these 2 systems handle are classified into device tools, which are the actual surgical tools, such as the scalpel, and the device kit, that is a set of 2 or more surgical tools that are defined and maintained together for a certain purpose. Finally, as a prerequisite to this process, the 2 actors share periodically the device master in order to keep it aligned. Now let's move into the process itself. And as step 0, we have that the operating theater defines and shares a list of device kits that it may use in its future surgical processes. These steps configures as a preliminary and also optional step that is not related to any particular surgical process. It just defines possible kits that can be used in future surgeries. As you can see from the picture, each kit and each tool is represented in our model by a dedicated device profile, and all of them are collected together in a dedicated list profile. During the planning phase of the surgical event, the operating theater defines which device kit needs to be prepared and, of course, associated to the surgical event. The operating theater shares this list with the sterilization center, together with task tracers for tools preparation, which status is in status requested, and the list of the tools requested are referenced through the input element of the task tracers. During this phase, if the desired kit has not yet been defined in the preliminary and, as I told you, optional step, the operating theater needs to define it on the fly. After receiving the tools preparation order, the sterilization center returns an availability feedback for the desired device kits, simply updating the status to accept it, the task status, I mean, to accept it if there is availability, or to reject it if it's not. And in this second case, the tool reservation process should start all over again from the previous step. When the sterilization center finishes preparing the requested list of devices, it will share kit and tool resource instances contained in a dedicated list. This list is referenced by the task for tool preparation through the output element in this case, and the status of the task for tools preparation is changing into in progress. Each kit and each tool instance is represented by a specific device profile. And as you can see in the picture, each device tool references a device kit resource instance through a dedicated extension, parent extension, with a one-to-one cardinality. After that, the device kits are physically delivered to the surgical unit, as Mario told you. The operating theater confirms if the requested device kits have been correctly composed by the sterilization center, and sends back the task resource with a status update to completed or failed. When the surgery starts, the operating theater informs the sterilization center about the usage status of the devices. And eventually can also add some details, some information about some defects that may occur with the device kits. The operating theater updates the device business status, which is another dedicated extension we created, to open or unopened, depending on the usage status of the tool. Moreover, the operating theater in this case creates another task instance, this time task for tools usage, and set this status to in progress. As last step in the process, the operating theater reports the device count after the surgery, as required by law in our case. And the last action this actor performs in this process is to close the task for tool usage by sending an update of the text status to completed. To conclude this brief presentation, we want to point out that this process has been designed, developed, and adopted also in order to reach a strong level of integration between the operating theater and the sterilization center to avoid as much as possible manual tasks, increase the patient safety, and reduce process cost. We are here available for any question. I want to thank you for having us in this presentation. And please, if you have any question, we are here.
Thank you, Mauro and Riccardo. Is there any question in the room here? Not so much here. Let me check on Rover. There is also no question on Mova. So maybe then a question for me, but I'm not so much in the domain, but does it mean that you have two different systems that speak to one another?
Yeah. I don't know if Mauro wants to answer this. Maybe I can.
Yeah. Usually we are in front of two different systems. So there is a system that can manage the operating theater in terms of activity inside the operating theater. And then we have another software that manages the sterilization processes. So the sterilization process is the process that sterilizes the devices that coming from the operating theater. And our challenge is to model the communication between these two software. So from one side, the operating theater, and from the other, and in the other side, the sterilization center.
So my question was also more a little bit like, do you centralize also this? So I understand that both systems talk to another, but indeed there is no aggregation like somewhere else, like in a whatever hospital system where you would push the result. It's stay in each system, and that's what you want. It's just the communication between those two. There is no extra centralization of what happened.
Honestly, Luis, I'm not sure I got your question. The two actors, yes, as Mauro said, are two different informatics systems. Let's say the one that manage the surgical process, the operating theater software, and the other one is the one that manage the, let's say, physical device sterilization process. The point of this project was to model a standardized way in which these two systems can talk one to another, and standardize the let's say the information that needs to be shared in the process.
Okay, no, so I got this. I was just thinking if there's an extra point where you centralize, you also share this information, but I think I understand it's two different processes, different system, and then you make sure that they talk to each other. So that's
the solution was modeled using the FHIR messaging paradigm, so it's a peer-to-peer integration, let's say, using FHIR and using FHIR resources, but still a peer-to-peer integration. The information belongs to the two different systems, let's say.
Okay, perfect. Thank you.
You're welcome.
So I guess still no question, so I will leave it there. So again, thank you for the presentation and this concrete use case. And then again, don't forget to fill the feedback, and then that's it. Thank you.
Okay.
Thank you very much.
Thank you for having us.